So there are two main ideas in calculus. First is rate of change, or how quickly something is changing. And second is accumulation, so the total amount or how much of something has built up over time. So in the first half of calculus, we focus on rate of change. You're already familiar with this actually from like your Algebra 1 course where you're looking at slope, right? So if you remember the formula y2 minus y1 over x2 minus x1, that gives us the average rate of change. However, in calculus, we learn this idea of the limit, and we learn how to take those 2 points closer and closer together in order to get the exact rate of change at a specific point in time, which is also just known as the instantaneous rate of change. So some key words here that you should kind of know is the secant line, which gives us the average rate of change, and the tangent line, which gives us the instantaneous rate of change. The main tool that you're going to use in the first half of calculus is the derivative, which basically gives us the instantaneous rate of change. You will be looking at many real life scenarios, such as speed, right? A car's velocity or rate of change. You could be looking at something like growth, so how much money you're getting per month, or even profit. So we can also use derivatives to look at a function's behavior, so where it's increasing, where it's decreasing, and of course, maximum and minimum values. The second half of calculus has to do with accumulation. So it could be the total distance traveled or the total amount of money accumulated. Again, we actually start off with a very simple concept, and we basically try to find the area under the curve by using rectangles. So then, once again, limits come into play because we basically learn as we take the number of rectangles to infinity, we can get the exact area under the curve, which is also used or found by using the definite integral. So integrals are the main tool that we're going to use in the second semester. These two big ideas of derivatives and integrals are tied together by the FTC. So basically, it tells us that integration is undoing differentiation. So differentiation and integration are inverse processes. We can use integrals to solve many real-world problems, such as the total distance traveled, the total area between two curves, and etc. So to tie this all together, derivatives measure rate of change, integrals measure accumulation, and the FTC ties those two ideas together and tells us that derivatives and integrals are inverse processes. Thanks so much for watching.